And good morning, all you wonderful people. Thank you for coming along this morning. I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. So, I hope everything is working. I'm doing this through StreamYard instead of just directly to YouTube. So what do we have? We got a whole bunch of people here already. 33 people already. Okay. Also, what morning? It's 1 a.m. Yeah, it is, Henrik. 1 a.m. If it says a.m., that means it's morning time. So, what am I doing? Okay, today we have Austin here to join us. And before I even get into saying hello to everybody, let's just get Austin in. We can say hello to everybody together. Austin, welcome to the stream.
Hello, folks.
So who do we have here in the chat? The two of us can do the welcomes. So, oh look, we've got Austin in the chat. What a surprise. Michael's here, Chip is here, Dodgy, Henrik, Russell, David, Mitchell, Tassie Bob, Kim, Gerald, Delane is here, Frank, Imogen. Thank you all for coming along. So, Austin, how have you been recently?
I've been good. I've been busy with many projects. And hopefully some of them are on your bench and you're going to have some fun with them.
Yes, I have magical mystery live stream content right here. Ready to go. All the way from Canada. Oh, Simon is here as well. Justin, I don't think I said hello to Justin earlier. Okay, so by way of background, there is the ongoing wireless access point project, ongoing across multiple years, which is an embarrassingly long time. And one of my goals for that project has been to be able to power the access point over the network, so using power over Ethernet. And one thing that I find personally really frustrating about PoE devices is that typically you have to buy a device for the type of PoE that you want. So there's standards compliant 802.3 AF and variations type PoE, and then there's DIY PoE, and the devices are not compatible with each other. And so one of my stated goals for that project was to be able to build an access point that you could plug into any PoE type network, whether you're just sending 12 volts down the wire or if it's using a proper PoE Ethernet switch or an injector, and have it just work without having to change jumpers and all of that sort of thing. My first prototype had jumpers that would allow you to bypass the onboard regulator and just send voltage directly down the wire. But I can't stand the idea of having jumpers on it. And it also introduces risk, because if someone leaves those jumpers in place and then they plug it into a normal 48 volt injector, then you could damage the board. And Austin took it on himself to try to solve that problem for me, and has gone through a number of iterations of circuits and testing systems that can detect what type of power is being delivered over the Ethernet cable and then adapt itself to suit, which is really, really cool. And so Austin is here to explain to me a little bit about how his idea works. And we have the magical mystery package, which has in it a prototype. So the instructions were that I was not allowed to open this until the live stream. Yes. So, Austin, where would you like to start? Would you like to give a bit more explanation, or shall we dive straight into the package, or what's the best thing?
I can give a little bit of an explanation. So initially, you had the question of how could we make this auto switching, and my brain loves a good problem to solve. So on one of my 10-kilometer night walks, it popped into my head. I wonder if I could set up a NAND gate to check certain things and conditions for over voltage, under voltage, and turn on a relay to allow DIY PoE to work. So that was my first circuit. It partly worked, but there were some problems. And I had already known of the IC that I ended up using. So instead, I decided to switch the IC for something more modern. In doing so, you do gain a few things. One, it's more purpose built. Two is that it's a smaller IC, so the overall circuit is actually fairly condensable for a project that you might want to embed it in and not have to worry about how much space it's using. And then as for what it allows, so somebody's already mentioned it in the chat that Cisco has a really weird PoE standard that is almost never used anymore. But I did put protections in place on the board so that even if it were used, you shouldn't have anything blow up on you.
Okay, so in that situation, it wouldn't work with that standard, but it wouldn't be harmed by it. Is that right?
Yeah.
Great.
And so the standards it allows is your standard 802.3 AF auto-negotiated, which happens on pins 1, 2, 3, and 6. Then you have your 802.3 AF passive, which happens on pins 4, 5, 7, 8. And that is anywhere from 37 to 57 volts, but typically would be 48 volts. And then you have DIY PoE. So that's whatever you're choosing to send down the wire. Typically, you'll see people send either 12 or 24 volts. And then again, those are also done on pins 4, 5, 7, and 8. And this circuit has a relay that allows that lower voltage to turn on the system and bypass your PoE regulator through a relay. And then if the voltage gets too high, it automatically switches back, and the regulator that's on the board takes over for that higher voltage before dropping it back down for your system voltage.
Fantastic.
That's
okay,
the
so
general overview.
Yeah, so then the output of all of that is a voltage at a known voltage. So you're regulating whether it comes in as nominal 48 volt or 12 volt or whatever, it goes through your regulator. So the output of this system is a known pre-regulated voltage. Is that correct?
Yes. Let me see here. I think I have one in the bin. Actually, I have an actual second board. So on the board, you have the PoE regulator that we've used on quite a few projects.
Yes.
DP
1435. Yeah, 1435. Yep.
So that takes in your higher voltage and steps it down to 12 volts. So that's handling anything that's high voltage. And then the regulator is my common switch mode LM2596. And that can handle a wide voltage range. And it's within the range that I've set that when it switches back over from DIY into passive mode, that you're within the range of the regulator so that you're not burning anything out with too high of a voltage.
Okay, that sounds good. Michael just pointed out in the chat the interesting part of Cisco PoE. Actually, I wonder if I can Yes, here we go. The interesting part of Cisco PoE is that it's basically the same as 802.3AF, but using different pins. And then, so you can make an Ethernet cable to make it work properly. So yes, you can basically just remap the pins. But yeah, it's horrible that you have to do that.
Just make sure you label that cable and it doesn't end up in the
Yeah.
bin and accidentally plugged in somewhere.
Yeah. Okay. So should I begin with the opening?
Yes.
I
Yes,
want
you
to
should.
open this package. Okay, cool. Let's get rid of that. And time to... Sorry, Michael. I just put Michael's comment up on screen and he said he feels violated. Yeah, that... Oh, hang on. What? I've got another one. So this is... Hang on. Can there be more than one Steve?
You have to see the base for it.
Okay. Okay, I have to see the base for this. So we have another squirrel. Okay. It's Steph. We got Steve and Steph. All right, so has Steph got a backronym yet?
Yes,
that,
Scott.
yes?
Scott has an acronym for.
Okay, so Scott's done that. That isn't Steve, it's Stevie, Mitchell said. That's not a Steve. Okay. So I got to put Steph on the stand and got to get Steve down off. Here we go. So there's Steve and now Steph. So sorry, you're saying what the acronym stands for?
I think I have.
Oh,
Scott happens to forget. Let me search Discord for it.
Yeah. I think, yeah. Well, Scott can put it directly into the chat.
Let's see. It's in here somewhere.
So maybe Cable Tie will need to print another little hard hat, but a smaller one, because Steph's head is smaller than Steve's. Scott said, stream to end Peter hopes. Yeah. There should be a comma in there.
Oh,
stream
yes.
to end Peter hopes. Yeah. Okay. Well, that is really cool. Thanks, Austin and Scott. Now, I'm going to need to make 2 chair mounts instead of just one, so I can have one on each side of the chair. So coming back to... so does it mean Steve is smarter than Steph? I don't know. What does that mean, Henrik? So, yeah, I need to mount Steve on one side of the chair, Steph on the other side of the chair. I can be chased by squirrels all day. Very cool. So now we have
would make
two mascots.
Would make for a conversation starter in a virtual meeting with a client. Just have 2 squirrels next to you.
Yes.
Oh yes, and Steph is Steve's wife.
Yeah. Okay.
The immigration papers finally came through.
Right, and it wasn't a wedding for a green card, like a marriage of convenience. Imogen said another option is stream to end. Pizza's hot. Yes. Hang on. I can. Where can I do this? I'm just because I don't normally use StreamYard. I'm not. I'm not used to pulling up the comments like this. Oh, that's cool. Thank you. Okay, I'm going to put those aside for now and get back to here. And let's see what's in this box. So we've got, this is a smaller board, it looks like. I don't know which one I should open first, but let's start with this. Ah. Okay, I think this is something to get back to. This is a follow-on thing, isn't it?
Yes, those are Oxrs related.
Yeah, okay. Let's get back to that. We'll look at the PoE part of it first. Oh, interesting. Warning, for cable use only, do not connect to any device, it will break it. Connect USB cable to both sides of the board. Ah, that's a USB cable tester.
Yeah, so that's an open source project that somebody posted on GitHub that's been becoming popular of late. And I had a few of those boards made, and I figured I'd send one along for you if you don't already have one made.
I don't, and that will be incredibly helpful. Thank you. So one of the big issues with USB-C, of course, is with all of the different pins, you can get cables that might be power only, just for charging, and different combinations of power and data. So being able to plug a USB-C cable in particular into this would be really handy. Okay, let's give this a little test. Now, Austin did warn me that I would need a CR2032 battery, so I didn't know what it was for. Maybe a really, really big watch, but I've got one here. So let's stick the battery in it, and I'll find a USB cable. The ones that I commonly use ages ago, when I was converting a whole lot of my boards to USB-C, I went onto AliExpress and bought heaps of these cables just with a USB-C outlet on them, and I've been using them ever since. And I've never actually checked what pins are connected. They seem to work okay for basic things, so let's plug this in. Hang on, let's see, what was that warning? The cable use only, do not connect to any device. Okay, yes, not to any device. So plug it in, and then what do we do? Is there a button to start it? Or maybe my battery is dead. Should that simply light up with all of the connected pins?
Yes, it should.
Okay. It's quite possible that my battery is no good. So what is it meant to be?
I would double check the way you put the battery in.
Oh, okay.
No, it goes from end to end.
Not like that, from end to end?
Yeah,
yep.
So...
All right, so... yeah, I might have put it in upside down. That is quite likely.
On the battery port, where it's positive, you want the cell to go in like that.
Yeah.
So that
Let's try that.
upper sets of pins are in place properly.
Let's try that. I probably just damaged the battery. No, it doesn't clip in properly that way. I think it was right the first way. I have a feeling that this may be a... I'm saying it's 3.3 volts. Oh well, I will figure that out. Well, that's really cool, Austin. Thanks. That is going to be very useful. So I'm going to mess around with that later and see what's going on. I'm probably just doing something really obviously wrong. Okay. So this is the board that we care about. So we've got Ethernet coming in. All right, so the purpose of this board is purely to implement the power extraction circuit and to test the theory, isn't it? This is just to make sure that the design is okay. So essentially, it's like it's the opposite of a PoE injector. It's a PoE extractor. You can put power in here and get power coming out here. Yeah. Okay, so I have, what do we need? We want to measure the output there. So
the easiest thing
give us 5 volts.
The easiest thing to do would be to just try if you have an auto-negotiating jack nearby, you could just plug a cable in and watch it turn on.
Yep.
Okay. So Stephen W. has pointed out the fact that there's a big red capacitor on this board, and that is for a specific reason. So that capacitor is a higher voltage capacitor, It's what I had on hand. Otherwise, I would have gone surface mount. But normally I use a 35 volt capacitor, but because of the switching going into a higher voltage range, the capacitor also had to be changed for one that's high enough voltage.
Okay. Sorry, I've just changed the layout to bring this up a bit bigger. Yeah, because the voltage that's coming in here could be quite high. So this is rated to 50 volts.
Yeah.
Yeah. Yeah. And with electrodes, well, capacitors in general, they need to be derated. So whatever voltage you expect them to be exposed to, you normally get them significantly higher rated. If you want to put 50 volts on something, you don't get a 50 volt capacitor.
If you look on the back, there's some specs.
Yeah. Cool. Oh, and you've got the pinout on here as well, which is very handy. So all the documentation is right there on the board. Yeah. Okay, so I'm going to attach. I don't know if I want to do that. Let's. I'm going to grab a couple of jumper wires. What I want to do is put the multimeter on the output side of this, and I'm going to grab a couple of jumpers. Have I got orange will do for positive, blue for negative. Yeah, really sticking with convention here. And then we're going to try putting different voltages onto the input side and see what happens. So Austin, this project that you doing this, I hope was not just for me. You've got some projects in mind that you're wanting to do power over Ethernet with as well, aren't you?
I do a lot of projects that involve power over Ethernet, but I have nothing that immediately needs it now.
Oh, okay.
I liked the challenge, and I was waiting for one of my current projects to start up, so this was something that tied me over.
Well, thank you for doing that. All right, so I'm doing jumper wires to jumper wires here, just so I can get it onto the multimeter probes. Somewhere I do have multimeter leads with alligator clips on them, but I can't be bothered looking for them right now. So this is going to have to do. All right, so we've got voltage output. This is the PoE extractor.
Mm-hmm.
And we've got a couple of options. I've got a passive PoE injector here. So what I can do is send voltage down the wire, and it will come out on the appropriate pins for passive PoE and an Ethernet cable. So the very first test we'll do is I will take this into here. So what we've got is Austin's module connected to a network cable. And you can imagine in a normal installation, this network cable would travel through the building. It might be 20 meters long or whatever. It goes into the location where the injector is. But for these purposes, I've got a little patch cable. So then at the other end, we can inject power down here. And I am going to, what am I going to use? I'll turn on my lab power supply, because I'm sure this is going to work, but my usual approach with powering up anything for the first time is to do it on a lab supply with the current limit turned on so that nothing bad can happen. So this cable is now coming from my lab supply and plugged in. So what do we set it to? Let's say we'll send 12 volts down the wire. Does that sound good?
Sounds good.
And I'll set it to a 300 milliamp current limit. So 0.3, go. All right, we're all good. You can't see it, unfortunately, but my lab supply is ready, and I'll turn it on, and we'll see what happens. Let's see if any smoke comes out. Ooh, I heard a relay click, and we've got 5 volts. This is all good.
So Mitchell's already started asking about why the capacitor is rated for 50 volts, whereas you might have a switch that has really high voltage. So the way the power path is currently working in your case is you'll see there's both a blue LED on and a red LED on this board. So the blue LED is indicating that it's decided that the voltage is low enough for DIY PoE, so it's turned on the relay. So the power is now bypassing the PoE regulator that's on the left and instead going directly to the switch mode regulator. And then the red LED is indicating that that switch mode is outputting voltage. Now, if the voltage goes high enough, in this case 37.4 volts, you'll see that blue LED turn off, and instead power will go into the PoE regulator and then go into the switch mode. And that PoE regulator outputs 12 volts. So the system would never see anything over the 50 volts that capacitor is rated for.
Yeah, so the worst case scenario would be if you were injecting, say, 36 volts down the wire, which is not quite enough to trip the circuit, and the 36 volts is going straight to the regulator, and the capacitor will be exposed to that 36 volts. Is that correct?
Yes.
Yeah, and then once it gets up past 37, it trips, and then this capacitor is no longer being exposed to that high voltage anyway. It's only being exposed to the 12 volts coming out of here.
Correct.
Great. All right.
And then there's actually a low voltage protection with the IC as well. So if you used your lab supply, you could drop it to, I think, 10 volts. Once it drops below 10 volts, it'll turn off as well. In case you had a really long wire run, it won't allow the device to turn on with too low of a voltage.
Okay, got it. I've got, so we would see in that case, this would turn off. So the output power would not be running.
Both of them would turn off.
Both would turn off. Okay. So on my lab supply, I'm going to drop it to 10 volts now. And it's on at this point, but now if I drop it, I'm going to take it down to 9 volts and we'll see what happens. Oh yes, very nice. I heard the relay go click. You wouldn't have heard that probably. This LED has turned off and then this one has faded off as the capacitor is discharged. And of course we can see that the output is falling. That's just the output of the regulator discharging all the way back to 0.
Now, how high does your lab supply go?
65. So we can set it to 36. I'll try setting it to 36 volts.
Yeah.
All right, we now have 5 volts on the output. We're getting 36 volts on the input. Everything is running as it should. And over time, if we were pulling much current out of this, so at the moment, all we're doing is measuring the output. We're not really drawing any load from it. But the regulator would probably start to become noticeably warm. But it's still well within the specifications for this regulator.
So that regulator is rated for 45 volts.
Yeah.
But they do have a high voltage version that's rated for, I think, 60 volts.
Yes. Yeah, I've used that higher rated version in a project just recently, actually. It's all pin compatible. It's just a slightly more expensive part, I think. So that is now working at 36 volts. So if we exceed that 37 volt threshold, it'll bypass this circuit and start sending power directly to this regulator module. And then that'll send the 12 volts onto here. Does that work nicely just with a normal DC input? Like if I put this up to say 40 volts now,
yep.
What should happen is the blue LED will turn off because the bypass circuit is not working.
A different LED turn on.
Yep. Oh, cool. And then the red LED should stay on as well. It's a little bit hard for everybody to see. I'm going to do this by voice. Sorry to everybody. Alexa, turn off the office lights. No, you can't see anything. You need some light at least. But at least you can see. Oh, I know what I can do. I'll turn on the microscope light there. And that'll do for now at least. So we can see the output LED is on. We can see the bypass LED is on. We've got 5 volts on the output. All right, on the lab supply, I'm now going to crank it to 40 volts. And go. Ooh, look at this. So now we've got this LED. There's a green one up the top here, which has come on. So that's showing that the power is coming through from this regulator instead. We still have output, still at 5 volts. Nice one, Austin. Okay, I'm going to take it up just a little bit higher. So that's at 40, which is at the bottom end of what this regulator module is designed to work at. I'll take it up to 48 volts, which is the nominal PoE voltage. So that's now running 48 volts input down the wire, just passively injected. And it's all still working. So one thing that I really like about this is that it works with the 802.3 AF style injection, but it also works with high voltage, just passive injection. So you can passively inject anything from just over 10 volts up to whatever this regulator can handle, which is like 56 or whatever the standard is, the spec is, and it'll just work. And it's not going to get excessively hot because it's all switch mode. This is really nice. Okay, so the next test is, let's do it with a PoE injector. I'm going to turn off my lab supply. This will all die off. And I'm going to disconnect this. So we have nothing plugged in on the Ethernet cable right now. And just over here, I have a PoE injector. So normally one part of this would go to the Ethernet switch, the other part of it goes to the device. And as you can see, it came with Chinese labeling on it. So I've made up stickers to indicate what the input and the output is. Now this is not, oh no, it's not currently plugged in. I'm just going to slide over and plug this in. There we go. Okay, so you can see there's a green LED now on the PoE injector. So if I plug this cable in, now I've got to say, Austin, it's kind of non-dramatic when everything just works. You've done this too well. So if I just stick this into the LAN side, and you can see once again we've got 5 volts out, and we've got the power output here, and we've got the indicator showing that it is not running the direct injection circuit. It's running through the PoE regulator. So we're now running nominally 48 volts into this from this 802.3 AF PoE injector, and it's working. Is there any scenario it doesn't work in? We haven't seen any smoke come out. Normally when I do these sorts of things, there are failures everywhere and everything's just working.
Now, granted, I have gone through a few revisions on this. So far, I hadn't had anything have smoke, but I've had issues where it wouldn't properly turn on. So in the case of this board, originally I was testing the jack that's on it, which is an Abercon jack that I use on my WT32 Ethernet PoE board because it has the clip and an upward orientation. And then you're using it on the access point for that same reason. But the other common jack we both use is a hand run jack. The only problem with that jack is that it internally combines the power pins from wherever they're coming from onto 2 sets of pins. The problem with that is because of the circuit that's detecting the passive or DIY PoE, it has extra resistors on the line, which an auto-negotiating switch will see that extra resistance and think it's a non-standard PoE device and not enable power. So they do need to be separated so that it can work properly, which in the case, as you saw, it is indeed working correctly. You'll also notice on that board, I do have 2 small wire links that I've put in. That is because I had a part, which I believe I put it in the package. It should be in a small baggie. What do you call it? It's a bridge rectifier. It's the same one that's used on the PoE regulator. I added that kind of last minute.
It's probably in with these other parts that we haven't looked at yet.
Yes, it might be in there. I added it kind of last minute because I thought the extra protection could be worthwhile, especially for something like you accidentally plug in a Cisco switch that's non-standard. It would protect against that. The thing I realized last minute and why I removed it is that it has voltage drop. That voltage drop is not calculated into the circuit to account for it. Now it won't. No, it would potentially hurt things, but the parts do have enough headroom for the 1 volt you lose. But on the revised version that I've already posted on GitHub, I've accounted for it and I made note of it in case somebody decides to make the circuit board without that part. The different resistor values you would want to use for both versions are there so that you can know what they are. But obviously, I would recommend keeping that diode rectifier in place because it protects everything. But the basics of how the circuit works, there is a subscreen error, which I did fix. The main IC is a TPS 3700, and it's a supervisor regulation IC from TI, I think. And it uses
that up. Yes, I'm just looking that up right now. I will drop the link to this in the chat as well.
It uses 3 resistors to monitor voltage, and those 3 resistors, depending on the values you use, set the low voltage and high voltage cutoff. In my case, I have bridged the outputs so that it can control the circuit the way I want. Posted on GitHub, I have both TI's. There's a simulation program called Tina that lets you run a simulation of a circuit to see how it's going to perform. I've posted both that, plus the Excel sheet that lets you try and calculate the resistor values for a potential circuit that you want to build with the IC.
Oh, that's very handy.
Both of those are very helpful for me playing around with resistor values because I was trying to find nice values that you can actually get the resistors for.
Yeah. Often in data sheets, I find that they will have. What I really don't like is when they don't have examples. Like when you find a voltage regulator and it says, this is the V-sense pin, and you put a voltage divider on it to do the sensing, and here is the formula. And then you've got to mess around trying a whole lot of different things to come up with sensible values, which can really take a lot of time. And on a lot of data sheets, I'll have examples like for a 12 volts output, use these 2 resistor values. And when they don't, it's really frustrating.
And then, so that IC allows up to an 18 volt B-in. So the main marketing is that you would potentially use it in battery applications. Obviously, in our case, it's going all the way up to potentially 60 volts if you're doing passive PoE. So instead, I have another IC on there. It's a really long number, so I'm not going to say that. But it's a 60 volt, 300 milliamp, 3.3 volt output regulator. It's really small, only requires a few capacitors and an inductor. And that's being used to power up both the relay and the what do you call it? The TPS chip, so that everything stays within the voltage range that it wants to see.
Okay, cool. We have a couple of questions. Aaron said, I'm assuming for this prototype, which demonstrates the auto power switching only, thus the data pins are not broken out, just in case people make one for themselves.
Yes. So I've already had a few people ask about like me condensing this design and designing it with multiple regulators, and even having like the W5500 on it, so you could easily integrate it into a project. And I'm sure I'll probably try that at some point. But for right now, this was designed solely as a test breakout, so it's got a bunch of pads on it with probe pins, so that you could see the various voltages and see the different states that things can be in, to understand the circuit and run tests if you want to change values for whatever reason. So this was purposely done, um, so that you can avoid that.
Yep. Yeah, it's really just isolating that particular building block of the circuit and proving that it works before integrating it into something a bit more complex.
There was another question asking about PSU rise time. So the TPS chip is set to only turn on at a certain voltage, but that circuit would already be active and running even at a lower voltage, because it'd be going through your because it's powered off a 3.3 volt regulator. So once you're above, I think, like 4 volts, that system would already start monitoring the voltage on the rail. So as soon as it was above its threshold, it would in fact turn the circuit on, so that even if you had a rise time that was really slow, it would come on. Your only potential limiting factor would be the inrush current that those capacitors will take. They will take a fair punch, from what I've seen.
Yeah.
And then for that question, so far I have not seen any glitching. I've found that the capacitors in the circuit seem to handle it quite well. And there are some diodes in place as well, so they should be suppressing any fast switching as well.
Yep. And Scott also suggested hooking up a scope to the output and cycling the power through the switch point. So the moment at which the relay is no longer bypassing the regulator. So if you go in either direction, I suppose you would want to see what happens as you rise through the switch point, and also see what happens as you descend below the switch point. So that is something that could be done. Right now, I don't have a way of putting a scope anywhere that you can see it. But I'd really like to do this. This is interesting. So perhaps next week, what I'll do in the meantime is there is an API for the Rigol scope, and I can pull frames off the screen over Ethernet, and I will figure out a way that we can do that. And so Scott, thanks for that suggestion. That would be really interesting to see.
And I know
if I tried to do it now on the stream, I would spend the rest of the stream messing around trying to set things up so that we could do it. So I won't do it right now.
And I know this is probably bothering Henrik. So on that power board, what I think the issue is, and I had this when I first tried putting a battery in, is the positive end of the holder has a weird tab that you kind of need to push the battery up into and then push it down, because otherwise that tab ends up under the battery, and then you're not actually connecting positive and negative.
Yeah. Keith made a good point. So Keith just suggested, what about the UniT meter? So that's true. What we could do, it's not the same as showing it on an oscilloscope, but at least what we could do is, with the multimeter here visible, I could bring the voltage up through that point, and we'll just see if the output changes. Now, I don't think we're going to see anything visible because we have the capacitance involved. and we're not actually pulling a load out of this. We're just
And
I could actually,
inductors.
and inductors and things. I do actually have a programmable load here, so I could connect that and start pulling a few watts out of it, just to see what would happen. Where is that adjustable load? Oh yeah, it's over there on the shelf. So I could do that. Yeah, as Scott said, meter's not fast enough. So it's going to look consistent if we switch it up through there. The scope is what we would need to see if there are any sudden little glitches and things that would happen at the transition. Dodgy wants to know what voltage do squirrels run on? I don't know. All of the volts all at once. Oh, okay. This is chasing a squirrel. I'm going to chase a squirrel about squirrels for a minute. This is a call out to the collective knowledge. There was a kids movie many, many years ago. It was an animated movie, and I think
Thinking of Over the Hedge?
could be Over the Hedge. It was one where I think we took my daughter to it when she was really little, and there's a bit where there's a squirrel that drinks a cup of coffee and then is zipping around so fast that you can't understand what it, and yeah, they play it back in slow motion so that you can follow what it's saying. Is that Over the Hedge?
Yeah, I think it is.
It is. Okay. All right, I got to go and find Over the Hedge because I have this vague memory of that
They
particular
made a second
scene.
one, if I'm not mistaken.
Oh, okay. And I just remember laughing so hard at that squirrel. Yeah, Jack's Tech says definitely Over the Hedge. And Chip says Hemi the squirrel. All right. Yeah, okay, so it was Imogen that remembered it was Hemi. All right, so you were just talking about the USB tester, and
Yes.
it's quite possible that I just screwed up the way that I clipped in the battery. So we can give that another go right now. Let's see if I do. Which way do I do it? That way, and then that, and then get rid of my face. And Alexa, turn on the office lights. And light. All right, I'm going to turn off this injector and move this out of the way. It's just dropped out. And then bring this back in. So there is a little clip that it needs to go under at the top end. Is that what you're saying? And then it clips down. Yeah. I see. So I've folded. Yeah, I see what's happened. I put it in from the wrong end first, and then it's bent down these contacts.
Yeah, it's a rather silly design when you're not familiar with it. I made the same mistake putting a battery in.
Yeah. Okay. So the positive is at that end, and that is positive, so it goes that way. Yes, and you've got to hook it under there and then clip it. Okay. So now we should have some more success. I've got to find that USB cable again. Here it is. All right. So truth time for the, what brand are these? US Lion USB cables that I've been using for years. And, oh, yeah, the tester is working, but you can't see the LEDs, which means I need to say, Alexa, turn off the office lights. There we go. All right, back in mood lighting mode. So we've got ground, and then on this side we've got V bus, D plus, and D minus. We don't have CC connected. Interestingly, I would have expected there to be two CC lines. So we've got CC2. Oh, okay, it's got CC1 at this side, CC2 at this side. All right, that is acceptable. I thought for a moment that what they would be doing is tying the CC1 and CC2 lines together, which is the classic mistake that the Raspberry Pi Foundation is never, ever going to live down. So, yeah, this cable is obviously only suitable for connecting, because it's was that USB-A at that end? because it's USB-A at this end, which only has 4 pins in it, it's never going to expose anything other than ground power and data at this end. So sometime, in fact, let's try this. I've got a USB-C to USB. I've got a few USB-C, USB-C cables here. Let's just try this one.
So Frank's asked the question about selling these boards. So I'm not selling these boards, and the reason being is it's not my project. Somebody posted them on GitHub. Included in those GitHub files were the files that allow you to order them through JLC PCB's PCB-A assembly service. And they're relatively cheap. For like 5 of them, I think it comes out to like $10 each or something.
Yeah, so that way people can buy them, order them, have them delivered, but approximately $0 of that goes to you, yes. Which is unfortunate. Do you when you do that? So with that, it's not like it's purely allowing people to use JLC's assembly service directly. You don't get any commission off it or anything like that?
No, it's someone else's project, and I don't want to go selling someone's project. So you can order them yourself.
Oh, okay. So you're talking about this one here.
Yes,
so
that one.
I thought you were talking about your PoE board.
Oh no, the PoE board I can definitely make if somebody wants them.
Yeah. Okay. Cool. Aaron in the comments has just posted the squirrel coffee scene. I won't click on that now because I don't want to be copyright infringed or whatever on YouTube, but I'm going to check that out later. Thanks, Aaron. Right, so what we've got on this cable is we have, my phone is going a bit crazy. I should have muted that. So we've got data, we've got CC2, but we don't have CC1 connected. That's interesting. We've got VBus on both sides and ground and data minus data plus on this side, but not on this side. Now, what happens if I turn this cable over? I'm going to rotate that 180 degrees, and it's still the same. So we've got CC2, no CC1. Yeah, I think this cable has a problem. I've tried to use this cable, but the thing is that when I got my current, so I got the Mac Mini, which has USB-A ports on the front, and I've got hubs connected to it. But I got my MacBook a little while ago, which is only USB-C. There's no USB-A on it. And I've tried using this cable to a USB-C target board and been unable to flash it. And so I put this cable aside to try to figure it out later. And Austin, you have now given me exactly the tool that I need to see what's going on. So that's very handy. So now I need to find a source of USB C to C cables that are connected appropriately.
IKEA, incidentally. I have a few cables and chargers from IKEA of late. I've both been impressed with the price and the quality of it, to be honest. The only thing I haven't found a source for is proper USB-C 3.0 compliant cables. Every cable, I thought I had a few, but every cable I've tested so far is not 3.0 compliant.
Okay. Right, so IKEA. That is not at all the place I would have thought to go looking for USB cables. I thought they didn't make anything smaller than like a chair.
No, they have lots of stuff, don't they? Nifty items.
Yeah. Although my guess is that electrical goods might be a little bit country specific. So here in Australia, if they carry USB cables, they may not be exactly the same USB cables as they carry in Canada or other places. Right. Earlier there was a super chat from Namocrafts. Thank you. That's very generous. And there was a question. Hang on, I'm going to pull this up. I have a question. Do you guys have an automation kit that includes a main board to send and receive the data and an app to control it? That is... okay, following on. I'm trying to automate my house by running Cat5 cable to each switch without changing the wiring of the house. All right, so this is kind of getting into the whole OXRS question, isn't it? And this could lead nicely into the other thing that you had in the package.
Indeed, it can.
Yes, so Nemo Crafts. I'm not 100% clear on the type of question that you're asking, but what we'll do is maybe we'll start having a look at the other thing, this other thing. Alexa, turn on the office lights. And in beginning discussion of this, maybe we'll talk a little bit about OXRS and help to answer NemoCraft's question. Okay, so what am I doing? Oh, this must be this is the little bridge rectifier that you were talking about. Yeah.
Yes. I sent an extra one along, so if you wanted to do testing and understand its characteristics, it's there if you want it.
Yep. Cool. Thank you. Yeah, that's a neat little part. Okay, so carefully pull this out. Oh. So this
that
is
one
an LED controller strip?
So I've now developed about 12 different boards for the OXRS system.
Mm-hmm.
That item there I recently revised. Originally used an actual D1 Mini. Instead, to keep the price roughly the same, but also make manufacturing easier, I switched for using the ESP12 directly, added USB 2.0 programming and debugging on it, and everything else for the design was kind of the same. I had somebody that initially wanted to buy some, but I guess didn't. So I do have some in stock now. But I decided to do a small test run because we've had some discussions about running a crowdfund campaign. I'm mostly set up to run a crowdfund campaign for the various items I've designed, which would give you a full system. The only thing I've been hesitant with is it's expensive, and I'm worried that I might bite off more than I can chew. So I've been a little hesitant to go forward with a campaign. But this is an LED controller. The LED controller firmware is actually one of our most variety contained ones. So it works on this particular board. It works on Tasmota LED bulbs, and it also works with an I2C enabled PCA chip. I forget the digits for it, but that chip allows up to 16 channels, and you can have a ridiculous number of boards linked together. I think upwards of like 64, so you can control a lot of LEDs with the firmware.
I think that might be the PCA 9685. Does that sound right?
That sounds right. And that's actually running my workshop because I have quite a few sets of LEDs here in my new workshop. And so what the firmware allows you to do is control anything from 1 to 5 channel LED strips. So in the case of what I sent you, I've sent a 5-channel strip. But in the firmware, you could go in and you could tell it how many strips are connected and how many channels each strip is using. And then the firmware utilizes fading, but it's mathematical fading. So if you're fading for a color strip, it would actually calculate the steps it needs to take to change the color. So the fading looks really smooth on it, and I've been quite happy with it. And I know a few people have these and they like them. And somebody actually built their own hardware on their own. They were building their own custom downlights, and it just so happens that the firmware worked straight out of the box for them, which is kind of cool to see.
That's great. So when you talk about 1 to 5 channels, so you've got 5 PWM channels here that you can control, and there are 5 chips right here, which I guess are
MOSFETs.
the MOSFETs that output, to each of those. And then this strip, so it's got, so what you've got here is it looks like it's got 2 different colors of white plus RGB. So that's why you need the 5 channels. So you can do RGB color through what looks like WS2813s or something.
The
Whatever is on the
5050 analog
5050.
ICs.
Yep. Oh, okay, of course. Yes, I totally forgot. That was a brain fart moment. So this strip goes the same color all the way along. It's not individually addressable. Yeah, and then you can control the color temperature of the white by varying between the 2 here. Now it's not so, it's a little bit hard to see on screen, but what you, because of the zoom and everything, but what's happening on this strip is that there is the RGB LED, then there are 2 white LEDs next to each other, then there's another RGB LED, and then another 2 white LEDs. But the 2 white LEDs are different. So one would be a warm white and one would be a cold white. And then by varying the proportion of them, you could change the color temperature of the white that you want to come out of the strip. So with the 5 output channels. So when you designed this and you specifically chose 5 channels, was that to accommodate exactly this scenario?
Yes. So I have both just the regular CCT, which is the same LEDs on that strip, but it's just the white LEDs, the dual white LEDs. And I have that exact strip, which is the RGB CCT, in my workshop, so I can have some color every once in a while. Like I like my mood lighting. But when I'm filming, just want more light to see what I'm working on, I can change the color temperature to match what I'm doing, but not strain my eyes at the same time.
Right.
And that board you can power either through the 2.1 millimeter jack, but that's limited to 2.5 amps, or you can use the terminal block. There's an extra 2 pins on the terminal block to inject power as well.
I see. So V and ground on there. And it's got an onboard regulator. So does the voltage that you put in here, does that need to match what is on the LED, or can it be a wide range voltage?
You would match it. So that's in a 12 volt strip. So you would want to feed 12 volts into it.
Okay. So I have my bench supply here. It's currently set to 48 volts. So let's not do that. I'm going to do V set 12 and I set, let's give it an amp, not that it needs it. The output's turned off at the moment, so I'm just going to plug it in. And then my guess is it will do something if I turn it on. Let's power it up. Maybe not. I saw
being an Oxrs device, what we've managed to do, I'm not sure if it was a function the last time you've played with Oxrs, but Wi-Fi based devices automatically start up their own access point.
Right. Okay.
So it's going to start up an access point so that you can give it Wi-Fi credentials, and then from there you'll be able to once it's on your Wi-Fi, you can use the admin UI to give it MQTT access and control it through the admin UI or through MQTT.
Yep. Okay, great. Now, I won't go through that whole process right now, but I just want to, I'll do this slightly off screen. Okay, here we go. So it's got Oxrs Wi-Fi has come up as a network. My guess is that's it. So I'll select that and password. Do we need a password for this?
It should be Superhouse.
All lowercase?
Yes.
Superhouse. Connect. Tap to view details. Okay. Nice. So we've got configure Wi-Fi, which would allow it to connect to my office Wi-Fi. And yeah. we can go through this process. Actually, before I do that, let's go to info. Uptime 1 minute 48 seconds. Got chip ID, information about it, how much memory is being used, and a whole lot of configuration options. Update. Okay, so it's got OTA updates. Oh, this is pretty cool. It actually explains the endpoints for the API right here on the page. That's a great idea. So you've got documentation in place right where you need it.
Yeah, that's using the Wi-Fi Manager library
Yeah.
project, and it's quite extensive what that project can do.
Yep. Cool. Okay. I'm going to jump out of that and turn this off for now. I'll turn off the power supply, unplug that. All right. So Nanocraft asked that question earlier about a central control system, and I was half keeping an eye on the chat. Somewhere, Dodgy said, sounds like Nanocraft is talking about the LSC, but whatever the main board is called, can't remember the name. So the LSC, I think it's the Rack 32 is probably what Dodgy's referring to there. And so maybe, I'm just wondering if we should talk about that a bit, or maybe this for now, which kind of will lead into the whole light switch controller discussion, I think.
Mm-hmm.
Oh, okay. So I'm going to need one of the touchscreen ESP32 boards to go into this, aren't I?
Yes, you are.
I think I can see what this is. Oh, this is cool. Okay, so let's, that is one thing that I did not have ready in advance, but I should be able to put my hands on one pretty quickly. There's definitely one here in this box. So it's one of those that you're talking about, isn't it?
Yep, the WT32 SCO one.
Yeah, so this one's currently attached to my, what is it? PCB conveyor controller. So I can take that apart. It may even have some firmware on it. I don't know. So we'll probably have to fix that. But okay, before I do that, let's have a look at this, and you can explain a little bit about what's going on here. So we've got a 3D printed enclosure, which looks really nice.
3D printed enclosure is a 3-piece design that lets you easily mount that to an electrical wall box. And I have various face plates designed so that it matches a few different types of boxes. There's a Wi-Fi version of it as well that's slightly slimmer. And then we're also experimenting with the new WT32 Plus screen, which might let us make an even smaller assembly. So to take this assembly apart, the 2 screws that are on the front, which you have facing up, can be undone.
Okay, I think this is the right. No, that's a slightly too big. Where is it? Somewhere on the bench just around here, I will have, oh, there it is. There's the hex driver for M3. So I haven't been paying attention to it recently. You mentioned the WT32 Plus. I've never even heard of that.
So it's relatively new. So it's pretty much the same thing. They built a better shroud around the screen so that you don't get light bleed, which is why this case is designed the way it is, to allow light to flow nicely. So that piece there that's in your right hand is the piece that would get mounted to your electrical box, and it's got 2 spots for that to go through. This the middle piece is what your screen mounts to, and I included the solderable standoffs for it. And then attached to everything is the Ethernet PoE shield that I've designed.
Right. Okay. So this is Ethernet PoE for the WT32.
Mm-hmm.
Cool. All right. So if I take that off and disassemble this, I'll be able to put the WT32 on here. I think this is going to end up mounted on my wall. I've got a spot for it where I currently have an Oxrs light switch with 2 buttons on it, and I think it needs to be replaced with a touchscreen. And then this is the bezel that suits the WT32.
Yes.
Yeah, this is neat. It all feels very solid. It's yeah, feels like it would be easy to put together and clip into place.
Yeah, I've had one
All right.
on my wall for 6 months, 8 months. It's been operating for quite a while. So with the plus screen, it switches over to using the ESP S3. The annoying thing is they chose one with 2 megabytes of PS RAM versus what the existing screen has, which is 8. So we've been having Moyne, who's been doing most of the firmware, absolutely fantastic firmware, is trying to see if everything will fit with 2 megabyte PS RAM. Initial tests so far look like they're working, which is cool to see. The screen also switches out for an 8-bit parallel connection running an IPS display, and the colors and contrast on it are absolutely amazing. I like it a lot. It also has better viewing angles. And then it includes an RS485 connection. It has built-in I2S, I2S audio, and USB programming.
Okay.
It does have limited I/O, but I think I'll still be able to design a different Ethernet adapter for it.
Yep. Now, I've just discovered something that might be a fly in the ointment, might scupper our plans. Hang on, I'll see if I've got another WT32. I've just been walking around the lab. Now, this one, which is the one that I just pulled off my my project, I've already soldered little nuts. I actually got heat set nuts and then soldered them onto the PCB, which means this will no longer fit on here because the nuts that I've put in interfere with the standoffs that Austin has got on his carrier PCB. So what I will do is put that aside, and hopefully in here I have more. It looks like I do. I've got another 3. That's a relief.
Part of the reason for those standoffs is I found that it's the perfect distance for everything to fit nicely. So on that large 40-pin connector that I've put on the circuit board, what I do is I solder it in place, and then it's got plastic on it from when it's assembled. I remove that, and it lets everything sit at the perfect height. So that there's minimal flexing on the design.
Yeah, cool. And Dodgy, I missed a few comments in the chat, but Dodgy said an Oxrs control panel, and basically that's the summary. Yes. So I think the point of this is that it's a touchscreen interface that can then be used for sending MQTT messages or whatever you want to do. So that could be used for Oxrs type input in place of clicky light switch.
Yeah, the firmware for it is quite extensive. You can do everything from LED bulb control if it's multicolored, or dim color temperature controllable. You got keypad control, so if you want to insert an alarm code, or if you want to have a keypad needed to switch the screen options, because you can hide screens. You can have multiple screens. Each screen allows up to 6 different tiles tiles can be text, whether it's getting temperature data that you want to read. There's a thermostat tile to control a thermostat. You have audio tiles, remote tiles, so that you can control interfaces. There's stuff for blind control. It's quite extensive, the options that are available.
Cool. Now I'm putting this together even though we don't have any firmware on here yet. I'm not sure if we'll get to actually doing firmware. I just wanted to see it assembled. So that is it with the WT32 in place and the bezel closed over it. I didn't peel off the front plastic. That's still there. So it looks not quite as shiny as it should. But that is very neat. So yeah, I think I'm going to have this on my wall in place of the clicky switches that I currently have here in the office. So this part is screwed onto the wall and attached there sort of semi-permanently. And then that acts as the mounting plate, and this can then slide on and be screwed on through these holes.
Correct.
Yeah. Okay. And then we could put plugs or something in there to fill those holes if we wanted to. So, all right. So on the back here, let's have a quick look. There is an Ethernet connector. Oh, and this is coming back to what we were talking about before. You mentioned that there are only certain Ethernet connectors that work with your power extraction scheme.
Correct.
And the one that you've got on here is an Abracon connector, which is a tab up connector.
Yes.
It's got the tab on the top of the, like away from the PCB. You can also get tab down connectors. And of course you can get vertical, like 90-degree connectors. So in the, for the extraction circuit, what we probably need in the documentation or just in the README or whatever is a couple of example connectors that we know work with this. So this one obviously works. And then if we can find one that is tab down that also works, that would be good. And that way people have options for what they want to use. What have I missed anything else in the comments? No. Let's see. Okay. Back to here. All right, so we've got Ethernet that comes in. Now this particular circuit, I assume this has been in place for a little while, does not implement your auto switching.
No, it does not.
It doesn't have the relay and those sorts of things. So this supports 802.3. So you can connect this to a normal PoE injector. And there is also a screw terminal on here with ground and VDD. So you could apply power directly into the back of this if you wanted to and not do it using PoE. And
correct.
Yeah, so this is the same voltage regulator as on here, I guess. That's the LM2596. Yep.
And the other thing you'll notice just past the logo on the shield is two little milled slots. So what those slots are for is when you have an Ethernet cable in place, you can run a zip tie through it to add strain relief.
Yeah, that's a really good idea. So you can plug it in there. I'm going to take it back out of the bezel so that we can see it. And that would need to be done before plugging in the WT32. So I'm going to remove this again. All right, just regulate backwards and forwards so I don't bend the pins. There we go. So you can see here that the two slots that Austin mentioned in the PCB are sort of in line with the cable. So you could put a zip tie or a cable tie through there and clamp that in place so that the Ethernet can't fall out. And it just gives you it takes the load off this connector. So you're no longer putting so much stress on the connector by pulling on the cable if this is in the wall and then the cable is going somewhere. So yeah, that's a really good idea.
And that also demonstrates why I used a clip up so that you can actually get the cable in and out.
Yes, exactly.
You can't get your finger around it otherwise.
Yes, because normally Ethernet connectors are mounted on the edge of a PCB and you can get to them from either direction. Like with this one, you could use either clip up or clip down and it wouldn't matter. But in this case, it absolutely has to be clip up, otherwise you're never going to get the cable back out again. So clip up. All right, so we've got the onboard regulator. This is the same regulator, the DP1435 that we've used on a few things. So that'll be giving 12 volts out, which goes into the LM2596.
Mm-hmm.
And then you get 5 volts out of that, I guess.
Yes.
Because, yeah.
Yeah, the screen requires 5 volts, so it gives out the 5 volts, and then the board taps into the 3 volts to power both the quick connector that's on the board, but also power the W5500 that's on the board as well.
Yeah.
And then tapping into the SPI lines, SPI lines for Ethernet connection. Now the annoying thing is it's using non-standard SPI pins, but also the library for doing Ethernet doesn't support multiple SPI lines going, which the display uses the high speed lines. So I had to go through and figure out how to edit the library to allow both to work properly. But the firmware does now support it, which is nice.
Okay, so does that mean that you need an edited version of that library to compile it?
You do, yes.
Yeah.
If you're compiling everything, we've switched the Oxrs code base to use Platform IO or VS Code. And then we've also set up GitHub Actions. So when the core team is making changes and whatnot, and we push them, we can tell GitHub to make all the newest version, and then it creates all the bin files for all the updating. So your average user won't actually need to compile anything. Even if you do want to compile it locally, the way Platform IO is set up is it has a configuration file and different libraries. Typically, if it's a GitHub library, you can post the HTML code in your configuration file, and it automatically pulls the latest version. So everything's automatic, which is really nice and handy. And you're not having to chase down zip files for updated libraries for compilation.
Yeah, that sounds like a really nice toolchain setup. Okay, so other things on this board. Up here, we've got the WISNet chip. So this was I'm guessing a 5500. Is that right?
Yes.
Okay, so we've got Ethernet coming in, goes through the W5500, which connects by SPI, as Austin was just mentioning, through this header to go to the ESP32 on the WT32. So then we've got a quick connector on here as well. You put quick connectors on everything, don't you?
I really do like that connector. So we have a version of the firmware. It's a debug version, but it's implemented. I put together an Oxrs library of different I2C sensors. So a few of my projects use them. The LED controller uses it as well. And so I've set my screen up on that debug version to allow me to hook up a temp sensor. So I have mine running, and I've been kind of keeping an eye on it. And most of the time, it runs between 5 to 10 degrees above ambient, which is well within the rating of the parts. It would last you tens of years, even at an elevated temp level. Now, it would feel warm to the touch, and I wouldn't recommend it, depending on how warm it is. But you don't want to. But it's all within rated parameters. And Mike just asked about MicroPython. I think it would run MicroPython as long as you have support for the W5500. And if I'm not mistaken, ESP already supports it, which is what the screen uses. But as for my main purpose, I haven't tried MicroPython on it because I'm running Oxrs code for the project. And my other project is a using the plus displays, and I'll be making custom code for that project anyways. So I can't get into much on MicroPython beyond that.
Yeah, it would really come down to whether the different peripherals are supported. Yeah, you could certainly. So this is actually gets into another thing I was going to bring up, which is different power options and networking options. So far, I've just been showing this with the Ethernet cable plugged in, and we've talked about PoE, but you don't actually need to use PoE or even Ethernet at all on this, do you? Because you've got the regulator on here, and you've got this input. So we've got ground and VDD. What you could do is simply use this as a voltage regulation board with the WT32. So you could have MicroPython running on the WT32, communicating over Wi-Fi, because there's Wi-Fi in the ESP32, and use this as a convenient way of mounting it on the wall and just run power into it from the back. So you wouldn't need the Ethernet cable at all. And
now I do have a second board designed for this display. It's a much smaller board, and it's purely it's an upright Ethernet jack combined with, I think, a 2.5 millimeter jack and a power regulator. And that board is specifically just DIY PoE or using the 2.1 millimeter jack. So it would allow, if you just wanted to run Wi-Fi or you needed a slim housing, which is why a few people have purchased it, and allows you to run just 12 to 24 volts on it as well.
Yeah, so that addresses the comment that Sion just made, which I had up on the screen a moment ago, that you'll want to make a custom build for it to streamline it. So in that case, it's not as heavyweight as this. It doesn't have all of the 802.3, doesn't have the WizNet chip on it.
Correct.
Yeah, it's just a way of conveniently powering the board. And then you could use, would it physically fit in this form factor? Would you be able to put it inside this enclosure?
Yes and no. So we have a second enclosure designed for it that shaves off a few millimeters from it because it's a lot smaller. And it uses the other position header on the screen. And it takes up like a very, very small amount of space, which is why it was designed.
Yeah, and this one is relying on your carrier PCB for mechanical mounting to the back plate. So without that whole size, it's just not going to mount there. You need those screw holes in the right place. Yeah. So DBR, it said, I was thinking maybe a magnetic front plate, then you wouldn't need the screws in the front plate.
Potentially, but I'm not sure you would want magnets that close to like, I'm not sure how I'd feel having magnets that close to both the screen or the Ethernet IC. And definitely not if you're trying to run Wi-Fi. You might not like that. Granted, I guess it would depend on how powerful the magnets are. I prefer mechanical mounting personally.
Well, I suppose one option would be, I'm not going to fully put this together now, but imagine it was all assembled in here and you had screwed this bezel on with these recessed M3s. It would be possible, it would make it slightly bigger, but you could make a shell that fits over the whole thing and just clips onto the front of this, and it could have two stakes that go into these holes for a bit more of a positive connection. So basically a press fit that goes over it and it overlaps everything and then gives you a smooth face.
Now, if I'm not mistaken, I think someone else in our group had actually designed a different version that clips onto the Clipsal designed plates, so that you can cut out a small section of it so that you can the electronics can fit nicely, and then they have a shroud that fits over that has nothing visible. It just has internal clips to clip onto the Clipsal lineup. But I designed this one As people have pointed out in the chat, I'm in Canada, and it's very common for electrical boxes to be in a house. Now we are allowed to run low and high voltage not combined in a box. We have separate available boxes to run low and high voltage, but they have a standardized spacing on the screw points. So my design has two sets of spacing. One's designed for North America. The one I sent you, I'm hoping is correct and works for Australia. The files are online if you need to change them. And I think there was a test design for UK, but I'm not sure if anyone's actually printed them off yet to test them.
Okay. Well, I'm going to give that a try with the wall plate, and I'll see if it fits. Hopefully it does. So Sion clarified. I misunderstood his comment earlier. So he says, no, I mean a custom MicroPython firmware build. MicroPython on the full-featured board should be fine, 5500 and all. Okay, so I thought Sion was talking about a cut-down version of the hardware, but he was talking about the software environment. So yeah, thanks for clarifying that, Sion. Right, so there were a couple of other comments I think that I missed. So Trady said, oh yeah, that's another option. So this is talking about the mechanical mounting. Mike suggested clip-on with small screw on the bottom. Yeah, so you could have a shell that hooks over from the top, slides down, and then put a screw in from underneath where it's not easily visible. That would be a good way to do it as well.
Oh yeah, well, I don't think John has firmware on the screen yet, but it could be powered up. Just need PoE on it.
Yeah, okay, we can do that. Oh yeah, Keith said, any chance to power it up? Dodgy's keen for that. Okay, so let's go back to here.
Actually, if I'm not mistaken, the screen from the factory is programmed with something, so it should turn on and become visible, if I'm not mistaken.
That's true. I think it does. Even though I just pulled this out of the box, like it came out of this supposedly new box, it may be that I have messed around with this and loaded something on it in the past. But we won't know unless we power it up and find out. So let's get this clipped in. And so these standoffs that you've got have threads in them. So the idea is that you would screw the PCB in from this side, but that's not going to be necessary in this case because it's already clamped between the two parts of the housing. So yes, I'm sure. Sorry, I'm just pointing that out for the benefit of people watching who can't really see the detail of what I can see here in person. I'm sure, Austin, you know all about it. So just squeezing that down to make it sit down. So I think that's all sitting in place. And now if we power this up, so okay, there are a couple of power options. With the screw terminals on here, just behind it, people can probably see there is a green pin header jumper. There are 3 pins on it, and it's got PoE marked at this end and X marked at this end for external. So this would be for source selection. It's currently in the PoE position, so if I send power through here, it will power up. If I wanted to use the screw terminals, my guess is I need to move that jumper across. Is that correct?
That is correct.
Great. Okay, so now going back to let's go back to the passive PoE setup. So I've got the injector here. What else do I need? You can't see it, but I've got stuff all over my bench here. It's all crowded with all the different things. So I need to find the power lead. Okay, so power lead, and then it's currently set to 12 volts, 1 amp. Then I need an Ethernet cable, got a short little patch cable here. Plug that in, and we'll try to get this somewhere that people can see it. plug it
Now,
into
in that
the passive
configuration,
injector.
you'd want to be powering it above 40 volts.
Ah, right. Okay. Yes, because we're using
Passive.
this passive. Yep. So I could actually plug it into this injector, but what I'll do is I'll just use the lab supply and do VSET 48, go, and then we should be right. So I'll plug that in, and I'll just turn on the lab supply. All right, it's powered up, and oh, look at that, it's come to life. So it's got the standard, well, except that I had it upside down. Yeah, so we are successfully powering it. I'll show you the front again in just a moment. So we've got power coming in over the network cable, and I'm currently sending 48 volts down it. It's being regulated by the DP1435 and then going into the LM2596, and then going into through the header and powering up the touchscreen. So the touchscreen is running the factory firmware that comes. I'll try to get the angle so that you can see it. It's kind of glary on the screen here. But if I get the angle like that, the touchscreen by default, when you get these, comes with firmware that flicks through different colors on the screen just to show that it's all working. And then there's this little drag thing. You can see there's a shape, and you can test the touchscreen by touching that and then dragging the object along, and you follow along that line. And once you got to the end, it takes you to this. I don't know what that says. I haven't ever tried to translate that. But yeah, that proves that the screen is working. It's all powered up, doing exactly what it should. Nice. So, Doji, does that satisfy you that we have life in it? Hopefully that's enough to justify it. I'll put the bezel back on. And so it would be mounted in the wall. Is the normal orientation to have the cable coming down or cable going up? Probably doesn't matter because you could change it in software. But which way do you normally do it?
I can't remember.
Or you could mount it sideways if you wanted to.
In software for the Oxrs, it is running one particular orientation. Let me see what orientation mine is in. The small little window that's on the front of the screen. There's a small little window on the front of the screen. It's pointed to the bottom now, so it would be the other way around.
Okay.
That small window is for an IC that they don't populate on these screens. It's supposed to be for a proximity sensor. I did actually buy a proximity sensor to test. However, I find it's highly inaccurate, and the glass makes it loose.
Yes.
Which is probably why they don't use it.
Yeah.
Which is kind of unfortunate.
Yeah. When I first got one of these, I noticed that little unpopulated area, and I thought that would be really handy to have. So it's a little bit hard to see. Well, if I get the angle right, yeah, you can see just there. If I get the light at the right angle, it looks like there's a little rectangle. It's similar to what you see if this was a mobile phone and I was holding it this way. It's like it's where the speaker would be that you stick your ear up to. But that is on the PCB, just underneath the screen. There is a little unpopulated area, and yeah, it would be really nice to be able to have this in a like in a dimmed state, and just come up and move your hand near it and have it wake up and come up to full brightness. But unfortunately, that hardware is just not installed.
But that would be your top. So when mounting it on a wall, that window is your up point. Yeah.
Yeah. Cool. So Andrew said horizontal orientation is more common in Australia. Yeah, I think it actually looks really cool doing it horizontally. I'll just say mounting it like that. If you're using it as a touchscreen, it's probably more useful like that than like that. Well, I'm going to experiment. The light switch that I'm going to be using, so what I'm going to replace with this is currently oriented this way. It's a 2-button OXRS light switch in a vertical orientation, and I'm basically just going to pull it off the wall. It's got a cable on the back of it at the moment, which goes to a light switch controller, and it's not going to work with this because we need 48-volt PoE, but I can just switch the cable at the other end because it's just RJ45 connectors and plug it into an injector at the other end instead of the light switch controller. So talking about the light switch controller, we've kind of talked around and not directly addressed the question from earlier. I can't remember the name of the user. Was it Namo DIY or something? Hang on, if I scroll back, I should be able to find it. Namo Crafts. So Namo Crafts was asking about the overall system. Oh, interesting. So Frank said horizontal here in Vic. Dodgy says more vertical in Queensland. Oh, now we're getting into it. That's why I call you Victorians Mexican. Stay south of the border. Right. Okay, so Aaron said this was in relation to replacing the firmware. So we can't use OTA initially to replace the firmware that is on the WT32.
Mm-hmm.
We need to use USB to get the initial firmware on there, and then once OXRS firmware is on it, we can do OTA updates from that point. But the firmware that comes shipped from the factory on the WT32 does not support OTA.
Correct.
Yes. Okay.
The good news is that putting new firmware on it is not too difficult. And then in your case, when you do eventually load it up, I've sent a Node-RED example that kind of shows you a few things. My example also links the LED controller that I sent you, so that you'll be able to actually see the different buttons interacting in real time.
Okay, interesting.
Or you can save it for another stream if you want to.
Yeah, well, we're 15 minutes from from. Hang on, I've got to remember what's the acronym. Streams that end pizza's hot. I think was the what Imogen suggested. And what was the other one? I need to make a record of it, otherwise I'm not going to remember. No, I can't remember.
Links. DIY Ghetto is asking about links for the device. I think Aaron had posted them a little earlier. If not, I'm sure he can repost them. I can probably find them in a little bit.
Yeah. So you're talking about the WT32?
I think.
Or
I
your
think it's
devices?
the screen, or if it's. But all the information is on the Oxrs.io. Information site.
Yeah.
We've been trying to get all the documentation up to date. It's most of it's there. I know the screen is one of our most extensive ones. Recently, we actually not really condensed, but we split apart a lot of the core items to support different items, like what do you call it? ESP32, your ESP8266. There's a LilyGo PoE Ethernet board that we've supported. So we've made custom core libraries for those types of devices so that it's very easy to build new code for new things. So we've also started making the code that runs the LSC. We've now designed to work on just a bare ESP32 or an ESP8266. So you could go in and configure what just your basic pins allow. And lots of options basically for what you can do with various items.
Yep. Okay. I'm going to make that link go away, which is too soon. Simon had a question of where did you get the footprint for Australian wall plates?
The measurements that I used, I got from a few people in the group that are from Australia. So obviously I'm hoping the measurements are correct. All my files are on my own GitHub. Most of it should either be on my own website or linked through my own website, I should say, or available through the different documentations on the website that John is currently showing. And I know Dodgy was hoping that I could show my thing that's on my wall. Unfortunately, I do not have a mobile camera currently active, so I can't easily show it. But all the examples are on, well, a lot of examples for things. Because one of the options in firmware, now I don't think it's an option we're going to be able to support on the plus screen because of the PS RAM issue. But on the screen the basic screen, there's a snapshot function. So you can actually go to its IP address /API/snapshot. I think you have to do .png. I'm not 100% on that. It's been a while since I've done it. But it shows you a snapshot of what the screen is currently showing,
Nice.
which is kind of handy when we've been doing this documentation. And this snapshot can show you just a specific tile, or it can show you the whole screen as one image.
That's really cool. Yeah, like remote screen capture off the Rigol scope almost. So this is showing some of the tiles that can be set up. So button level up. So this is just a simple on-off, and then this one is for adjusting light levels, button level up, button level down, blinds, button up, down, button left, right, indicator. Okay, so colors, select album. Oh, Kodi integration. Okay, thermostat, tile payload. So it can have, is this because it can have either dark mode or light mode, or is that just showing the state?
That shows the state.
Okay.
So in that section of code there, that's the configuration code to get that specific tile to show up on the screen. And then you'll see that it shows config, state, and command. So you'll get various payloads depending on what you're trying to do. So if you want to set the state, then you would, when it detects a state, it sends information back to you. And then the command is something that you're going to, what do you call it? To change the state. And then you can add sub-label information, and you can tell it how long it's been on, or various things like that. And then so Dodgy just asked about a DHT sensor. So currently it is designed to be completely standalone. So if you wanted to use the text tile to display sensor data, that data has to come in through MQTT. Now, if you're running we might do an official build of it, but right now it's a debug version that enables the quick connector that's on my Ethernet shield. So in my case, I have a temp sensor running behind the wall for me. So you could theoretically just through MQTT directly display that temperature data right on the screen. But ideally, if you're trying to get a room reading, you'd want the temp sensor away from heat source like the Ethernet PoE.
Yeah, even ESPs can run a little bit warm. So in that small enclosure, you're going to have the voltage regulator and the ESP, and the backlight for the display generates a bit of heat. Yeah, I'd expect that if you put a temperature sensor inside it, it's probably going to read 5 to 10 degrees higher than reality.
Yes, that's what it's been doing. So right now, my room is reporting 27.4 degrees Celsius, and the screen is saying 37.8.
Okay, yeah, so that is a significant difference. Yeah, this is a link that Aaron just sent, which is like a, this is really cool. It's just like a mock-up of an ad for an Oxrs system.
Pretty much.
Yeah, you can see the Oxrs logo down there and the touchscreen on the wall. This looks more like a tablet sort of interface though, so it's like an iPad or something stuck to the wall.
It's funny that you mentioned tablet because someone in the group has been on their free time slowly been building HTML version of the firmware that we have, so it will function the exact same way, um, but as a website. So you could load it on a tablet. Um, as a website and interact with it the exact same way this does, because some people want to have larger tablets in their home and like the larger common areas like a kitchen where it can see everything in the house, whereas from room to room you'd probably only need a few tiles, so you would use something like the WT32. And yes, my room is warm. Part of the reason is I have extra insulation, especially during my renovation. I put in some sound foam to better isolate my room from those around me in my house, as well as my computer is running. I also have 5 computer monitors. I have my own network rack. I have my soldering oven in here. I have my 3D printer. So it gets warm in here even when it's cold outside, which outside is 4 degrees right now. So it's been a mild day today, considering we got 20 centimeters of snow yesterday.
20 centimeters of snow, right? Yeah, this is going on and on. Like I've been scrolling for a while, and I'm not even halfway down this page. There is a lot of information on this page about all these different tiles.
Yeah.
So it's showing all the parameters, the MQTT topic, a description of what it does, and a screenshot. So the work that's gone into just creating this, and then we've got config, state, and command for each one. The work that's gone into creating this documentation is enormous.
It's been a
so
huge team effort. I know quite a few of us absolutely loathe doing documentation as much as it is needed. But even just the firmware that's being done and the cycles of testing each thing as we push them is great. And like I said, there's numerous devices that have been built now. I have 12 of them myself. I ended up designing the LSE, but in a modular format so that you can mix and match boards. So I have that both in your LSC format, but I've also taken Frank's design for using an LM339 analog comparator to monitor end-of-line resistors for security sensors and combine that into an 8-port board so that you can monitor security sensors. I've designed what I've called Oxrs Black, which is a remix of the Rack 32, but I add in I2C hot swapping protection. I've added built-in KNX support, isolated RS485 support. Part of the reason for the RS485 is I have a potential design to change the display that we're using in the rack, but it would have its own backpack with an ESP8266 running RS485 in an attempt to try and have better communication and not have Ethernet lock up because of spy communications happening on a really long cable. But I haven't tested the theory yet to see if it would actually work or not. So I have that designed. I have the LED controller you have. I have a second version of the LED controller that's designed to work with the LilyGo Ethernet PoE board. It's an ESP32 enabled board, and it's like $20 on AliExpress. It's a rather nice board. I wish it had a few extra pins on its header, but other than that, it's a pretty good board. What else? Nice. Quite a few. I have the power shields for the WT32. I've already designed a modular rack case that could be manufactured as well. Unfortunately, the minimum order quantity is definitely up there in order to accomplish it at a reasonable price point, but that's why I've been hesitant to potentially run a crowdfund campaign, because I think the Oxrs system could be a really good system. It's just getting the marketing out there and having the interest in buying it that would need to happen.
Yep. Yeah. So while we're on this page, I scrolled down towards the bottom and I got to this section which has firmware installation, initial setup, Windows 10. There's information about how to prepare an icon for use. So if you're wanting to make a custom tile, cable tie, hey, cable tie just arrived. Cable tie has entered the chat. And
in the demo I sent you for Node-RED, I did include a few tiles that do custom icons for you to see how that works as well.
Yep, cool. So we've got here the initial setup, Windows 10, workflow to commission a new touch panel. And it'll be quite similar, I guess, doing it on Linux or Mac. So I'm going to have to check that out later. And so Andrew asked, KNX, CBus, MBus compat. So this is for OXRS more broadly, I guess. And
so the Rack 32, somebody designed a shield for it. So I know a few people in our group are running KNX. And the LSC firmware, it's not in the base firmware. I think somebody has a fork running where there's a spot in the code to add some lines of code for failover support. So if it loses MQTT connection, as long as you've programmed it ahead of time with address information, the LSC can directly take button presses and control things on a KNX bus. Now it does in failover, it gives very minimal support. Push the button, light turns on. Push the button, light turns off. Whereas if you have extra functionality where it's controlling multiple things and whatnot, as far as I understand, you start to lose a lot of your automation support. But I'm sure you would clue in very quickly, hey, I need to reboot my system so that MQTT and all your motion sensors and everything start working again.
Yeah. I think it might have been Ben who was using KNX. So I'm pretty sure that he had a shield to go on the Rack 32. And in fact, in the process of designing the Rack 32, the reason it has that little extra expansion header is to expose the second serial port pins, because Ben wanted to put a KNX interface board on it. So Keith asked, any recommendations for WT32 SC01 or the WT32 SC01 Plus? So Keith, that question, you're asking about recommendations of where to buy it? I'm not quite sure.
The easiest option is AliExpress. I've been buying somewhat larger quantities, so I've been going direct to the manufacturer on Alibaba. And because of that direct connection, my next project, I'm using the Plus display, but I'm actually swapping out the circuit boards on them because I need different I/O available, and it's just easier to change out the board. But because I was doing that, found out main supplier of them is now starting to source just the screens themselves for hobbyists, so that if you wanted that display but you wanted to customize it, you end up being able to buy just the display and not have to buy the control board as well, which is a nice option.
Yes, it would be. Well, a couple of people have been talking about the countdown and a lunch. Yeah, so Aaron said, this one needs to be highlighted. Moin, Ben, Austin, and Frank have done some amazing work to get Oxrs where it is. Well done, chaps. Hats off and thank you. Yeah, there has been so much work that has gone into it, and it's amazing to see what's been done while I have been entirely ignoring it. And very talented people have been making this system, and I just get to play with it, which is cool. So we're pretty much out of time. I am going to get some firmware running on that touchscreen because my objective is to get your system with the PoE mounted on my wall and running, so I can control the lights in the lab here with it and other things. I mean, as people have already seen on this stream, I have voice control of pretty much everything in here, like every bit of test equipment, soldering irons, and like everything is all controlled using MQTT, and it's all essentially part of the Oxrs ecosystem. So what I could do with the touchscreen is have tiles to control different things around the lab, and do nice things like have a button which is a leaving button, and then have that make sure everything is turned off, turn off anything that could possibly burn the place down, and have nothing left on as I'm walking out the door.
Well, even beyond that, you can use the, I don't think it's in the documentation yet, but I did put it in my example. There's a keypad tile. So you could even lock things out so it ignores commands until somebody inputs a keypad code.
Fantastic. Okay.
I have not built any yet. That was part of my hope for a crowdfund campaign, is that it would generate the, because right now I live on low income, so a lot of the boards I've been producing are mostly done at cost and hand assembled myself. Whereas if I want to do a large enough batch, I need the investment income to do so. And almost the bonus of myself potentially running something is that other than a few boards, almost everything I've made for Oxrs has already been assembled and tested and is in a few people's installations so far. So it would be a low risk campaign. And I did post my link to my website where I have up to date vendors of all the various devices that I've built.
Yep.
And hopefully, as things go along, I'll end up producing more.
Yep. So there would be fairly low technical risk. It's more about the practical issues of taking orders or pre-orders, assembling the quantity required, shipping them all over the world, all of that sort of thing. That's a lot of work.
Well, the budget came back to produce everything in minimum quantities that makes everything worthwhile, and I've put in a big buffer for everything. It came in at about $30,000 would have to be raised, which is no small amount of money. And I would set a stretch goal that if we can hit 20,000 above that, I can get vac cases manufactured. And buying them at the 20,000 start range, I would be able to price those cases at about $120 each, which I think is attainable. But anything below that, and the price starts creeping up really quickly. And the way I've designed that rack case is it would be modular. So you'd have all the cutouts you could want for the various items, but if you're not putting in a full 36 port, 48 port, whatever, you don't have to cut out those sections. It would have tabs in place to hold blanking plates in place for everything. But yeah, the logistics of doing all the QC testing and checking all that stuff would be interesting, to say the least.
It would certainly
which
be a
is why
big
I've been
commitment.
holding off. In the meantime, I've been working on a project for a nonprofit, and so I've started live streaming just this past week, doing some testing boards, and hopefully I'll be live streaming more of that progress on my own YouTube channel as I go along.
Great. So I think it's time for us to wrap it up. So on the screen is the URL to go to Austin's site with the Oxrs related items on it. And of course, from there, you should also subscribe to Austin's YouTube channel and follow along with the projects that he's working on. Austin, thank you very much for coming along today. And thank you so much for sending me this hardware. It's really cool to see the idea turn into something and have it sitting right there working on the bench. And the fact that you went through multiple iterations to get it to the point where it is today, it's a really good achievement.
Well, I had the design working, and I figured actually sending a physical assembled board is good for your own testing and validation, but obviously the design's on GitHub, so you have something to work from.
Yes. And also, thanks everybody for coming along to the stream. We are going to jump out now, and I'm sure Austin will come back on in a future stream. And in the meantime, everybody jump on Discord, chat, and go and build something awesome. I'm just going to pull Austin off for a moment and end the stream. So thank you very much for coming along, and see you next time.